All right, so today we're going to start taking a look at graphing linear equations of the form y equals mx and y equals ax squared plus c. So they're just two forms. It's really the same equation. There's just a little bit more in one equation than the other. So with this one, we still have mx, a, just m changes to a, and this one is a little bit more of a standard form. Because usually we have ax squared plus bx plus c. So this is the standard form, like the letters they use for it, so that's why they switched it to a. But really, it's still that same idea. This is squared, and this is not squared. So this is going to be a linear equation, and this is going to be a parabola or U-shape. Okay, so I amend my first statement. They're not the same equation. They're different equations, but we use them in a very similar way as far as graphing and solving them. So with these two, we actually only have the two that are very much in this order. The only difference with this one is we have a +1 on the end. So when we're going through and doing this, we want to choose points to graph. And I always have students choose 3 points just to make sure that you have kind of a nice straight line there. As far as if you only do 2 points, that's all you need to make a line. But that third point is kind of a check to make sure that you do in fact have a nice straight line. And I always do 0, 1, 2 unless I have a fraction. So we'll talk about that in the next one. But generally I just do 0, 1, 2 because it's very easy to deal with. So in the middle here of the table, and this is not something that Alex creates for you, you have to create your own tables. You can put your work in the middle here. So I have y equals 2, and instead of x here, I'll switch my colors up here. So I have y equals 2 times, I'll just fill this in with blue here so I don't have to keep switching my pen back and forth. So the first one I picked was 0, right? So 2 times 0, well, y is going to equal 0, right? 2 times 0 is 0. So my first point is going to be 0, 0. So I can actually put that right here on the graph, 0, 0. My next point, I chose 1. And 2 times 1 is 2. So my point is 1, 2. So I'm going to go 1 and then up 2. So remember, x is right and left, y is up and down when you're doing your graphing. And then my last point there that I chose was 2, and 2 times 2 is 4. So I'd go 1, 2, 1, 2, 3, 4, and that does look like a nice straight line there. Grab the line tool, and boop, boop, boop. Something like that. And I get to go backwards with it because it doesn't do, it's a little easier than, oh, I didn't line that up very nicely, did I? It's going to be a little bit off because I didn't line it up nice and perfect. Now when you do this on Alex, all you have to do is click on 2 of the dots and it will snap it for you. You don't have to worry about that back and forth piece. This is just my drawing tool here. And I just didn't go far enough to know where to start. I should have counted it before I started there. Alright, so that's the basic idea of graphing that line. So the next one, same idea. But instead of choosing 0, 1, and 2, 0 is still perfectly fine. Generally, 0 will work out because when you multiply by 0, that part's going to cancel out and you'll just be left with either what's being added or subtracted. But if I did 1 and 2 and I'm multiplying that by a fraction, well, then I'm going to still have a fraction. So what I want to do is look at that denominator, and I want to use multiples of that denominator because what that'll do is help me cancel them out. So I'm going to use 5 and 10. Now you do want to be careful about the numbers you're using. You don't want to go more than 10. Sometimes the graphs go to 12, but generally you want to stay pretty low for both x and y because although it is still a solution, it is a correct point. If it's not within the grid window that Alex gives you, you can't graph it. So just be careful about that because you don't want to do a whole bunch of work with all these big numbers and then not be able to use them. Even though, yes, they are correct, you can't graph them if they're not within the window they give you. Alright, so let's go ahead and look at this one. So we have y equals -3/5 times x. So y equals negative 3/5 times x. And, sorry, I got a little sloppy on that last one because I started to write a 5 instead of a 3. All right, so the first number I did choose 0 still because anything times 0 it cancels out. It becomes 0. So 0 plus 1 is 1. So that's my first point, is 0, 1. So 0, I'm not going to go right or left. I'm just going to go straight up to 1, like this. And if you remember, from I'm 1 and I'm 2, Math 8, and even in I'm 3, all the classes have dealt with what's called y equals mx plus b, slope intercept form. So y equals mx plus b. So if you remember this form, you can definitely use this to your advantage because b is the y-intercept, and that was 1. Look at that. We just went on the y-axis at 1. And then my slope, which is the m here in the equation, would be then negative 3/5. So I can actually use that to graph my next point. Or I can complete the table here. So I have 5, and the reason I did that is because 5 divided by 5 cancels out. It becomes 1. And I just have negative 3 plus 1, which is negative 2. So now I have my next point. So I'm going to go 1, 2, 3, 4, 5, and 1, 2. And then I'm going to do my last one here, which was 10. And 10 divided by 5 doesn't completely cancel. It becomes 2. But now I just have negative 3 times 2, which is negative 6. And I can add 1 to that, which gets me negative 5. So I go 10, which I believe 5, 6, 7, 8, 9, 10. Yeah, my graph goes to 10. And then we go down to 5. 1, 2, 3, 4, 5. There we go. We can see that's a nice straight line. And I can even test out that slope idea. So I go 1, 2, 3, 1, 2, 3, 4, 5. And look at that. I land right on top of that. If I went down 3 and over 5 again, I would land on the next point. So let's see. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. So I'm going to go right there just to give myself a reference point on putting this line. So it goes from here to there. All right, so there we go. And that slope intercept form also works on this one. If you, again, remember that, it's a very convenient form. There's nothing being added here, so what it means is plus 0. So it means it's going to cross the y-axis at 0, which it did. And then this is rise over 1, which would be 2 over 1. If I don't see under, it means it's a 1. So I go up 2 over 1. Look at that, I land right on that, up 2 over 1. So I can use that method as well. All right, so this was graphing linear equations in the form of y equals mx. We really didn't touch on the next one here. All right, so I hope that helped, and I will see you in the next video.